Hello, Golden Bears, Algebears, we might say. It's Algebra 1. We're starting a new topic today. So I want you to get out a fresh sheet of notes, and I want you to start on these three warm-up problems right here. I want you to simplify these expressions. So pause the recording right now and see what you can remember about exponents. Ready, go. All right, we're back. Let's simplify these together. 1 over 4 squared, you should have gotten 1 over 16 because all we're doing is squaring 4 and it remains a fraction. All right, now let's look at this next one. This one adds another element. We have a fraction with a exponent in the denominator, and that whole thing is raised to the power. Well, if you remember your rules about exponents from the fall, you can actually, in a sense, distribute that exponent, that 3, to each piece. And when you have an exponent raised to an exponent, you multiply them. So we have 3 to the 6th now. And if you simplify that further, 1 to the 3rd is 1. And 3 to the 6th, we all know off the top of our heads, right, is 729. Good. So again, remember there, 3, you have 3 squared, and you're raising that to the 3rd power, and you end up multiplying those together to get 3 to the 6th. Okay, last piece, and we're more familiar with these right here. We're used to doing something like this. We have 2 to the 3rd over 2 to the 6th, and we could multiply it all out and simplify, or we could recognize that, remember our rules here, that you subtract when you're dividing. So this will simplify to 1 on the top, and it will become 2 to the 3rd on the bottom, because in a sense what we're doing is 2 to the 3rd minus 6. But we'll get to that in a second, so we'll come back to that. But what this would reduce to is 1 over 2 to the 3rd, which is 1 over 8. So hopefully you got those. But this leaves an intriguing question, so we'll look at this, because if you look at what this would give us, it would give us a negative number up here, 2 to the negative 3rd, and that's where we're heading right now. So buckle the seatbelts, because my dinosaur friends are about to teach us about something brand new right here. Now, as a reminder, as always, as we always say in here, keep things positive. Guys, even if you're like this sad dinosaur over here who can't clap his hands, poor T-Rex, doesn't have long enough arms, but his buddies over here, Badly Drawn Dinosaur and Unexplicably Happy Dinosaur, are saying, hey buddy, keep things positive. And I want to remind you, in algebra, keep things positive. You are capable of simplifying, solving these expressions and equations, and keep positive with yourself, especially when we're dealing with negative exponents. With negative exponents, we want to keep things positive. So in your notes, start a new header, negative exponents, and I want us to try simplifying these right now. So pause again and try these algebraic expressions, simplifying them. Ready, go. Okay, we're back. Let's see how you did. Now, my guess, and actually we're going to go to the next page. I'm going to solve them here. And whoops, I'm going to put the shade back up. This is what you probably did. My guess is what you probably did is you simplified the bottom. You recognize, oh, that's going to completely simplify out to 1. And then the top, that 9 is going to become a 6th, and this will become x to the 6th. Now, you probably did that. Now, if you remember our laws of exponents, and when we have division specifically, what we are allowed to do is subtraction of the exponents. So we could have done this way. We could have said x to the 9th minus 3 equals x to the 6th. And notice we get the same response there. All right, now let's look at this other expression, x to the 3rd over x to the 9th. We've just flipped it. It's a reciprocal. Well, again, you probably simplify the same way. The numerator to 1, the denominator, that 9 will become a 6th, and you got something like this, 1 over x to the 6th. Now, let's try the same subtraction down here and see what happens. And I told you we were leading here with our warm-up. X to the 3rd minus 9, what does that give us? X to the negative 6. Now, this is what's new, negative exponents. And if you look at those, they're clearly different expressions. 1 over x to the 6th, x to the negative 6, could they be the same? And in fact, they are. And that's where we're heading today, is that if you have something like this, x to the negative 6th, that in fact is the same as 1 over x to the positive 6. Those two expressions are equivalent right there. So in a sense, the reciprocal is equivalent. So you can make a negative exponent positive by moving it to the denominator. Or conversely, if you had it the other way around, you can move it to the numerator. So that is our rule today. I want you to write this down. Know this right here, says our badly drawn dinosaur friend. I love that guy down there. His eyes are all in the wrong place. If you have an expression like this, so x to any negative number, any negative exponent equals 1 over x to the positive of that exponent. And then we have the converse of that written next to it. If you had 1 over x to the any negative number, you could rewrite it as positive if you moved it to the numerator. So we want to keep things positive today, and we've just shown how we can do that. All right, so let's try some examples here. Level 1. Level 1 examples, 10 to the negative third, something like that. How could I make that positive, keep things positive here, like unexplicably Happy Dinosaur is telling us? Well, 10 to the negative third I could rewrite as 1 over 10. Now again, we make it positive, right? 10 to the third. And then we would just do the multiplication from there. So 1 over 10 to the third is 1 over 1,000, and that would be simplified. Okay, let's try another example here. 5 to the negative fourth. I think you can see where this is going. 5 to the negative fourth would be equivalent to 5 to the positive fourth. And then if we simplified that out, if we did the multiplication there, we'd have 1 over 625. And notice we still have fractions here. We're still in the denominators. That's 625. We don't move it up. We don't move it back up. We leave it as a fraction, just like this. All right, and finally, 16 to the negative 1. Well, that's going to be the same as 1 over 16 to the positive 1. And 16 to the positive 1 is just 1 over 16. So there you go. Keep things positive. Like I said, not too bad. All right, let's look at some more examples. Level 2. All right, now we're introducing something new here. We have 5 over 5 to the negative third. What do we do in this case? Well, 5 to the negative third we can think of as 5 to the first. And if we want to make 5 to the negative third positive, we move it up. So we'd have 5 to the positive third. So 5, the green expression, is equivalent to the blue expression. Now, what is 5 to the first times 5 to the third? Well, remember, we add exponents in this case, so this is really 5 to the fourth, and 5 to the fourth is 625. All right, another example you might run into is something like this right here, b to the negative first raised to the negative third power. Now, you could go about this a whole bunch of ways. You could flip things first, or in this case, we'll do the multiplication first. Remember that when we have an exponent raised to an exponent, we multiply. So b to the negative first to the negative third is the same as b to the third, right there. And that's it. That one is solved. But you also could have solved it another way. You could have recognized that you had b to the negative first is the same as 1 over b, right? And that's all to the negative third. And then if you distribute the negative third, we would have 1 to the negative third over b to the negative third, and then we'd have to keep things positive, so we would flip it around, so we would have 1 to the negative third is just 1, and b to the negative third, we would move it up to make it positive, and we would have b to the third. So 2 ways to go about doing that one. I think the top way, what we did first, is the easiest. Okay, final one right here. We have 3x to the negative first. All right, again right here, let's distribute that exponent through. So 3 squared is going to be 9. X to the negative first to the negative second will be x to the negative second. Now remember that negative 2 up there is just on the x. So if we want to keep things positive here, we want to keep things positive, 9 over x squared is what that would simplify to. All right, 2 more examples. 2 more examples will make things even more complicated, but you can handle it. We're going to keep things positive here. How would we rewrite each of these expressions? Well, the first one, that 3 to the negative fifth, how would you do that? Well, if it's in the numerator, we keep it positive by moving it to the denominator. And look at our denominator. 3 to the negative fourth, that will become positive if we move it to the numerator. So I'll rewrite this as 3 to the positive fourth, because we moved it up, times 3 to the third, over 3 to the positive 5th. All right, now, if I do my rules of exponents in the numerator, then I really have 3 to the 7th over 3 to the 5th. And that will reduce to 3 squared, because 7 minus 5 is 2. And that would be 9, is what that would reduce to in the end. Okay, and one final one here. 2 to the negative third over 5, and that whole quantity squared. Well, remember, we can distribute that exponent, so let's do that. So we have 2 to the negative third to the squared, so that'll be 2 to the negative sixth, and that's over 5 squared. Remember, that exponent goes to both pieces. Okay, now 2 to the negative 6, we want to keep things positive, so we need to move it to the denominator. Now, remember that there will be a 1 left on top in this fraction, so we'll have 2 to the 6th times 5 squared, and that will be the same as 1 over 64 times 25, which will give us 1 over, I believe, let me do that calculation, that gives us 1600. 64 times 25 is 1600. So there you go. There's some great examples that'll help you with your work today, so make sure you check out the class site to see what your practice exercises is. But before you do that, in your notes, what I want to check before you get going on the practice exercises is I want you to answer this question in your own notes that Badly Drawn Happy Dinosaur has posed for us. In your own words, explain how I can simplify negative exponents and make them positive. Or positive. I apparently spelled that wrong right there, so let's get my English correct. It is a dinosaur after all. Positive. Big question mark. Answer that question, use complete sentences, make it very clear and concise, and we'll catch you soon. Thanks.